Hello everyone, in today's video we are discussing about the previous video's continuous. In previous video we are solving the axioms. Here also we are solving the axioms of field. So now we are solving the closure properties. So closure and the addition. So I did the level 1 in the previous video. So now we are doing the level 2. So our first question is determine whether the sets are closed and an addition or not. So our first question is even integers. So even integers are in the form of 2, 4, 6, 8, 10, 12, 14, and etc. So I just take a two elements from this. So I just take a 5, 8 plus 10 equals to 18, which is also belongs to this even integer. And I just take another two numbers like 12 plus 14, which is also 26, which is belongs to even integer. And I just take another two numbers like 1000 and 2000, which is equals to 3000, which also belongs to even integer. Since these all are even, so we are saying this is also even integer. So by that, what we are conclude, if we take any two numbers from the even integer, I definitely get an even integer. So this is works for all even integer. All the terms in the even integer, this is works. So all the terms which is there in even integer, so the x which is for all the integers, so for all x belongs to even integers are closed under addition. So by that our first one is solved. So next we are going with the odd integer. So next we are going with odd integers. Odd integers 1, 3, 5, 7, 9, and etc. So here I just take a two elements 3, 5, which is equals to 8. This is not belongs to odd integer, right? So now I just take 3 and 9, 3 plus 9, which is equals to 12, which is also not belongs to odd integer, right? So I just take another two numbers like 7 plus 9, which is also equals to 16, which is not belongs to odd integer. But these things are existed in the even integer, right? So these things are existing in the even integer, but I can take any two elements from the odd integer, I can add together, but I don't get the term which is there in odd integer. So for all x which is belongs to the odd integer are not close under addition. So by this odd integers are not working. So now our another question is non-negative integers. Non-negative integers. So non-negative integers are 0, 1, 2, 3, 4, 5 up to infinity. So non-negative integers also called as the whole numbers. So I just take a two elements from here. So 1 plus 2, which is gives 3. 3 is existed. So I just take a 7 plus 8, which is 15. This is also existed in non-negative integer. This is likewise. And if I take 0 plus 1, which is 1, this is also exist. I just take a 0 plus 0, this is equals to 0, which is also exists. So this third one, non-negative integers, is exist in the condition. It satisfies the condition and it is exists. So our next one is rational numbers, q. So they are in the form of p by q, where q is not equals to 0. So I just take a two elements like p by q in the form. So I just take a 2 plus 1 by 2 equals to cross multiply these things and cross multiply. So I just take 2 by 2 into 2, which is sorry, cross multiply these things. So in the denominator it's a 4. So 4 by 4, which is equals to 1. So 1 is in the rational number or not. So 1 is there or not? Yes, it's there because the denominator contains a 1. So it's in the form of p by q, where q is not equal to 0. So 1 is also there in rational numbers. So by that, this is belongs to q. This is belongs to q. So I again take another two numbers like 2 by 3 and 3 by 5. 2 by 3 plus 5 by 3 or 3 by 5. I together like getting 10 plus 15 divided by 15. So which is equals to 25 divided by 15. I get 5 by 3. So 5 by 3 is also an 5 by 3 is also belongs to q, and the q is this q is not equals to 0. So this also belongs to q. So by that what we are concluding, for any x which is belongs to q, for any x belongs to q are closed under addition. So this fourth one is also satisfied. So our next one is real numbers. So real numbers are containing all the sets. Real numbers. Real numbers are containing all the sets like natural number, whole number, integer, rational, irrational. So this all contains in real numbers. So by that, what we are saying. So if I take any numbers, like I can take an integer 0 and 1, which is belongs to real number. So I just add 1 plus 0, which is equal to 1. That is also belongs to a real number. Or else I just take an irrational number. So irrational number, which is uh, root 4 plus root which is belongs. So I just take two these elements from the rational numbers, but it is also there in real numbers. So I just add these numbers, root 4 plus root 2. I get 2 plus root 2. So this is unpaired terms, but it is also there in real numbers. Why? Because here I get 2. It's in a whole term, so no worries about that. But it is not be in the form of like the integers or any others. It's in the form of a root. So I cannot able to write this as in a whole term. I just write this as in the form of 1.414 in the decimal points. So I add together 2 plus 1.1414. It's also going etc terms. So I just take the few terms after the decimal. So I just add together, I get 3.414, which is belongs to, or because it's in the decimal point. The decimal point is also there in the rational numbers. The rational numbers are contained by the real numbers. So this is also contained in real numbers. By that, what we are saying, for all x which is belongs to R are closed under addition. By that, we are concluding these all things satisfies the closure property under the addition. So we'll see in the next video. Thank you for watching this video.